Good evening, students. Today we are going to start the lecture 2 of the session data structure. In this session, we are going to concentrate on different types of data structure that are available to us to be used in different areas of application. We know that data structure is a very important topic when we are concerned about storing of data and providing specific operations on it. Now, as per our previous discussion in lecture 1, we have seen that data structures are quite useful because they provide us a format to store data, to restructure data, so that we could arrange them in such a manner that they provide us efficient management of the data as well as provide us flexibility to perform various types of operations on that data. So our previous discussion was based on this particular aspect. Now, in this session, we will discuss more about data structure, their types, and their different areas of application of these different data types, data structure types. We will also consider some important data structures which are not in your syllabus, but they are very much important as well as their other counterparts. So let us begin our journey of understanding the different types of data structure and understand the different application area of these data structure, these different types of data structure and their modeling. So let us begin our journey. So now let us start with our discussion about the different types of data structure. As you know, why we need different types of data structure? We need different types of data structure as per our special requirement in a special situation. All these data structures are helpful to us in different environments, in different special conditions where we need them. So based upon our conditions, based on our programming situation, we need these different types of data structure at several places. So instead of having one single data structure, we require this mixture of data structures because several different programming situations demand several different types of data structures. So let us begin with our discussion with categorizing the different types of data structure. Let us categorize different types of data structure first, and then we should move on further. So types of data structure. Basically, a data structure can be broadly classified or broadly categorized in two ways. Number one, linear data structures, and other is non-linear data structures. In case of linear data structure, we have arrays, we have linked lists, we have stacks, we have queues. In case of non-linear data structures, we have two different forms of it: trees and graphs. Though trees and graphs are not covered in your plus 2 syllabus, but we will see, we will look for, uh, we will look what are the different aspects of these two data structure. We will not go into much deeper understandings of these data structure, but we will see, we will conceptualize, we will try to conceptualize these data structures as well, along with other linear data structure which is part of our plus 2 syllabus. Now let us move on further. Arrays, we will talk about array. As you know that array can further be classified into two different types: one dimensional array and two dimensional arrays. One dimensional arrays and two dimensional arrays. So now we will talk about each of these data structures one after another, so that we could get familiarized with these type of data structures, and further in our next few lectures we will discuss about the implementation, the C++ implementation of these data structures in broader perspective. Today we will only just look on to each of these data structures to get familiarization about the concepts involved around these data structures. Okay, so let us begin our discussion with arrays. Arrays, as you know, you have learned in your earlier class, class 11, what are arrays? Arrays are nothing but they are collection of similar type of entities. They are collection of similar type of entities under a single name, under a single tag name. If we are collecting similar type of entities under a single tag name, then that particular tag name is the array name, or the collection of those whole elements, or the collection of those whole entity is known as an array of element. Now, as we can conceptualize the array by drawing this figure out, you can have, say, suppose for example I am drawing a single dimension. We are talking about, first we are talking about one dimensional array. We are concentrating on first dimension or single dimension array. What is it? A single dimension array is nothing but it is a linear collection of elements. These elements can be integers, they can be float, they can be objects, they can be structure. So it may be any type of entity which can be collected and stored. They are stored linearly in contiguous memory locations. Now what do you mean by contiguous memory locations? The meaning of the term contiguous memory location means whenever this array will be created in memory, each of its element will be situated adjacent to each other in adjacent memory locations. Say suppose for example, if I have this array in which the collection of elements is like this: 20, 30, 40, 50, 60, 84, 96, minus 2, minus 12, sorry, 24, 89. Say suppose I have this type of collection of integers. This is an array having collection of integers. Now we can see that how many integers are there: 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. There are total 10 integers in this array. So we can say that this array is an array which has total number of 10 elements, and each element is designated in this array, in a one-dimensional array. Each element is being designated by a unique index number, and we in C++ we are used to start this index number from 0, starting from 0, 1, 2, 3, 4, 5 and so on, like this. The last index will be 9. So our index in this case, in this array, will vary from 0 to 9. Now we can say that this particular value which is stored inside the array constitutes what is known as element of the array, is known as element of the array. Element of the array. So we have two things. We have index, and we have element. What is an element? The value which is stored in an array is known as its element, and the position at which this value is being stored is known as the index or subscript of that particular element. Though if the total number of elements in an one dimensional array is n, say suppose n number of elements are there, then we can say that if n is the size of the elements, total number of elements in an array, then we can say that our index number or the subscript or the positional index will start from 0 to up to n minus 1. Okay, so I hope this have been taught to you in your earlier class, in class 11. So we will not discuss much about it. Just conceptualizing the old thing. We are getting us familiarizing with all these older concepts that we have already done. Okay, so without wasting our time, let us move on to the next thing, that is two-dimensional arrays. What do you mean by a 2D array? What do you mean by a 2D array? Let us concentrate. A 2D array is nothing but it is just like a collection of elements, just like we have collected elements in case of 1D array. In 2D array also we are collecting some elements, but we view or conceptualize this collection in a format of a table. That means the collection of element is viewed in the format of a table. In a tabular fashion they are formatted, such that the table is consisting of a fixed number of columns and a fixed number of rows. For example, I am drawing it 1, 2, 3 and 4. So I have a table having 4 columns, then I have 4 rows, 1, 2, 3 and 4. So I can say that it is a 4 by 4 two-dimensional array or 4 by 4 matrix. A two-dimensional array is also known as matrix, as you have done in your class 11. Now we can see that in a matrix or a 2D array, each element is stored something like this: 20, 30, 40, minus 15, 6, 0, 15, 8, 9, 7, 64, 22, 19, 45, 6, 18. Say suppose these are the collection of elements, then we can say that this particular element can be positioned or can be located in this matrix or a 2D array by two things: its row number and its column number. This particular element can be designated in this matrix or can be located in this matrix by its row number and column number. Here in this case, the column number is extended from 0, 1, 2, 3 and the row number is extended from 0, 1, 2, 3. So I can say that this element 40 is having a row number equal to 0 and a column number equal to 2. So I can say that the position or the positional specification of this element 40 can be located at 0, 2. So the coordinate or the index for this element 40 is 0, 2. So here in this case we are observing that to locate any element in this matrix we require two types of index, the row number as well as the column number. So hence it is a type of two-dimensional thing in which two dimensions are needed. The row number and the column number are needed for specifying the position of a particular element in this particular case of array. So This 2D array is also needed in various types of situation where we need this type of representation, where we need a matrix type of representation or a tabular fashion representation. We need this particular data structure, 2-dimensional array. So unknowingly we have known these two things in class 11, but they are one type of data structure. They are a type of data structure. The 1-dimensional array and 2-dimensional array are also a type of data structure which is required to structure data in a special situation. For example, arrays are needed to store elements in contiguous locations of memory. That means each element will have an address. Subsequently, each element will have an address whose value will be n minus 1 than the address of the previous element. So I can say that we will discuss about the addressing schemes and all that in broader sense when we will deal with these arrays in a separate lecture. We will deal this particular topic. For time being, I must say that this particular data structure is very much useful when you are going to collect few elements or a group of elements in memory area, in contiguous memory area, where you need some common operations to be performed on these different values or elements. So why the array is needed? It is needed because we can perform some sort of common operations on this collection as a whole. So it's a collection of elements and we can do some common operation on this collection as a whole. Similar is the case with 2-dimensional array, where we are collecting the elements, the values in a matrix format, and we can roam through each value and can perform similar type of operation with each of these values in the matrix. So let us continue our journey with next type of data structure, which is known as linked list. Now, a linked list is a linear data structure. I can say that it is a linear data structure. Why I am saying it is a linear data structure? Because the data are streamlined linearly and they are related with each other in a sequential manner, in a manner where we can say that it is a unidirectional, in a unidirectional manner or a unidirectional defined manner. The data are being arranged, they are sequenced. But remember one thing, that there is a huge difference between the concept of arrays and the concept of linked list. We will discuss it further. For the time being, let us conceptualize the concept of linked list using a sort of figure. I am making one figure, you just concentrate on this figure and then we will be proceeding with our discussion. A linked list can be conceptualized or can be viewed as similar type of thing as I am drawing over here. A bogies of train, you can think, a train having separate compartments, separate bogies attached to each other, and lastly null is here. So now a linked list can be conceptualized or can be viewed like this particular figure as I have drawn, where these things are known as, this particular thing is known as nodes of the linked list. They are called as nodes of the linked list, and within this node there are two parts. One is known as the data part. This part consists of what is known as the data part of the node, and another part, this part is known as the link part, or the link part which is linked to the next node in the series. Okay, so we can say that in a way that each of these nodes are connected to each other by using its link part. So the previous node is connected with a particular nth node is connected with its previous node by using the link part of the previous node. The link part contains the address of next node. It stores the address of the next node so that a link is established between these two nodes. So like in a similar fashion, this particular second node holds the address of the third node, and this third node holds the address of the fourth node, and so on. And the last node, as you can see here, the last node, the fourth one, the last node is holding the address null. That means we are ending our list, or we are going to end our linked list at this particular point when a particular node is pointing to or is not keeping the address of any other node, it is keeping an address which is null. Then we can say that we are ending at this particular point we are ending our linked list. Okay, now one main difference between arrays and linked list I want to bring to your notice, that in array the collection of elements are sequential, they are streamlined, they are unidirectional, and that's why we are calling it linear. In array also we know that these elements are allocated in memory contiguously in the manner that they require sequential memory locations. They require sequential memory locations at a stretch for their allocation. Say for example, if I have an array of size 10, then of integers, say suppose I have an array like this one, int a 10, then this particular array A will need 20 bytes of contiguous bytes. It will need 20 contiguous bytes in memory together. It will need 20 contiguous bytes in memory together to allocate itself. Now why 20? Because a single integer holds 2 bytes of memory. Since it has 10 integers, the capacity of 10 integers to be held, so 2 multiplied by 10, that makes 20 bytes. 20 contiguous bytes is needed in memory for allocation of this array A. Now the situation may be that in some cases the situation may be that your primary memory may not have 20 contiguous allocation. It may have memory spread out here and there. It may have 20 bytes of memory, but those 20 bytes of memory are not on the same place. They are not stretched at the same point, at the same place. They are not grouped together at the same place. They may be spread out in different areas. These 20 bytes. In some area it may have 2 bytes. Another area it may have 2 bytes. Another area it may have 2 bytes. Similarly, in 5 different areas it may have 2 bytes. So that together makes 10 bytes. But an array to be allocated, it needs 20 contiguous bytes of memory, which is a bit disadvantageous thing for us when we are going to allocate an array in memory, because if those 20 contiguous bytes are not available to us in memory, we cannot allocate array in the memory. We cannot allocate array in the memory. In that situation, what has to be done is that the memory area has to be compacted by a certain operating system program. It has to be compacted, and then those chunk of memory areas spread throughout the memory area space has to be collected together at one space, and then the array will be allocated a contiguous byte space. So this particular process is not done in every situation. Sometimes we are not able to allocate memory for this type of arrays during runtime. Another disadvantage, the greater disadvantage of array, is that the size of the array is fixed. When I am talking this array A contains 10 elements, that means I am fixing the size of this particular array as 10. That means not more than 10 elements can be accommodated in this array. Its size is limited to 10. That means in case if I want to store more elements, I have to declare and add new array with more number of capacity, with larger capacity. So during runtime I cannot include or I cannot accommodate more elements than the described size. Though we can dynamically describe the size of array, we will see that, but after all those things we are not able to dynamically grow or increase the size of array as we require during runtime. So this is a second disadvantage of array, that the array does not dynamically grows itself. Okay, during runtime it does not grows its size itself, so the size is limited and fixed. And the first one I have described, that they need contiguous memory allocation. Now these two disadvantages has been removed totally by one data structure known as linked list. A linked list is a special type of data structure where the nodes of the linked list, as I have told you, these nodes are created, these nodes are created during runtime. These nodes are created during runtime. These nodes are automatically created. They are created in the memory and they are connected with the previous node using the link part of the previous node. And in this way, this particular array of nodes or this particular list of nodes grows itself dynamically during the runtime. It's not needed that you will fix a total number of nodes. It's not needed that your program will be binded by total number of defining the total number of nodes. Your nodes may grow to indefinite numbers as much as you want. You can grow this list up to maximum extent you want to. Okay, so a linked list is basically more dynamic than an array implementation or array data structure. So linked list is a special type of data structure which stores element in a format, in a linear format, and the list is ever growing. That means we are able to grow this list as per our requirement, as per our need. We can grow this linked list dynamically during runtime. During runtime means during the execution of program, as we require, we can increase the size of this list, we can grow, we can accommodate more and more and more elements. Now, I must say you that in this data part, the element value is contained. For example, 20, 30, 40, the element values are stored over here, right? So we will talk about this linked list and its implementation further in a separate lecture about them, about the topic linked list. We will have a separate lecture, we will have a separate session just to get familiarized. I am presenting it over here with this topic. Now, another point of discussion about linked list I must be pointing out is that linked list does not require contiguous bytes of memory. That means these nodes can be allocated randomly here and there. These nodes can be allocated randomly in a random fashion here and there in the memory area. The only thing is that each node must keep the address of next node so that all nodes are get connected with each other. They are connected with each other. We must remember that we have to connect each node, otherwise we will not have a list. Okay, so the two different point or the 2 point of difference, I must say, that the linked list bear rather than their counterparts or array counterparts are, the two big differences are non-contiguous allocation in memory, and the next important factor of linked list is over array is what is dynamic grow during runtime. Okay, so I must hope that you might have understood what is linked list in a nutshell. We will describe it further. Now let us go further for our next data structure. We will talk about our next data structure, which is known as stacks. A stack is a special type of data structure which holds elements. That element can be integer again, it can be float, it can be long values, it can be objects of classes, it can be structure elements. Okay, so it can be any element. It holds the element in a fashion which is known as LIFO fashion. It holds the element in a LIFO fashion. That means last in, first out. This is the fashion in which the stack holds the element. Now what do you mean by stack? Stack means keeping the things above each other in a fashion that it get stacked up, it get piled up. Okay, now we can view conceptualize diagrammatically the stack as this particular vessel. It is a type of vessel, one open-ended vessel. That means at one end it is only open. This particular end is called the top end. This particular end is known as the top end, and whenever an element is pushed into the stack, or it is being thrown into the stack, it can be thrown into the stack using the top end only, and whenever it is taken out of the stack, whenever an element is taken out of the stack, that too you have to do from the top end only. So that means there are two types of operation we can do on this stack. That is, we can throw elements into the stack and we can take out elements from the stack. For example, now let us observe this thing. For example, I have a stack of integer. In which I am pushing, or I am going to throw one element called 20 inside it. My first element is 20. So what will happen? My top is over here. For the first time, when there is no element, my top is over here. I am pushing 20 inside it. This 20 will go here. Now again, in the next iteration, some other time, if I am pushing what? 30, my next element is 30, then again I am pushing this element, and this can be again pushed on the top. Always remember, you have to throw the elements on the top only. That means this 30 will be on the top of 20. Again, if I have another element called 40, then again this element will be thrown or will be pushed on the top area only. It can be pushed on the top area only, 40. Now observe that when we are pushing or when we are throwing elements in this type of fashion, actually the element which is thrown last is on the top. So when it is time to take out elements, this 40 will be taken out first. Whenever we are taking out the element or popping it up, that is called popping. Checking out element is from the stack is known as popping. So whenever we are popping out elements, this 40 will be at top. Since the 40 is at top, and I have told you that whenever you are pushing elements onto the stack or taking out element from the stack, you have to do it from the top. So at the top position 40 is there, so I have to take out this 40 first. So my first element to be popped out will be 40, leaving the stack like this, 20 and 30. Since 40 is being taken out, my top will be again what? 30. So if I am again taking out this element from the top, that means 30 will be taken out. Now you can observe that the element which was thrown at last into the stack is being taken out first, and that's why we are naming this data structure as LIFO, last in, first out. Okay, so this will be discussed further. We will discuss these things further in our special sessions on stack. We will discuss this particular thing. Now let us move on to our discussion on to a next type of data structure, which is known as queues. Let us understand. Let us concentrate on queues. What are queues? Queues are also a special type of data structure in which we arrange element or we structure the data or the element data. That element again can be an integer, it can be float, it can be long, it can be objects of a class, it can be structure, right? So we will arrange or we will structure the data in such a fashion in which it implements a law called FIFO. It implements a concept called FIFO. FIFO means first in, first out. Now what does this first in first out means? You might have seen there are many situations in real life. We are queuing up, we are making line to take certain service. Say for example, in a ticket reservation counter, we are in queue. Several people are standing in queue to take reservation tickets. Nowadays, though it is seldom visible that you are going for a counter ticket, you are booking it from IRCTC site. But still, if you are going to counter, you can see that in counter we are having queue like this one, as I am drawing it. I have a queue in which the elements has to stand in a queue fashion. The elements has to be standing. They have to be standing. At the counter end, this is counter from where you will get the ticket. At the counter end, the ticket will or the service will be provided, and at the back end, the peoples will keep arriving. The people will keep arriving and keep standing from the back end. So in queue, we can see that the particular element or the particular person who stands in the queue first will get the service first, and hence the concept is known as FIFO arrangement or first in first out. For example, my element which goes to my first element which goes to stand in the queue first is, say, suppose 20. Then I am going to have next element coming in line, and then I have what is known as next element. My next element is say suppose it is 40. My next element is 65, or I have another element called 18. I have another element minus 9. So likewise, the queue can grow from the rear end or the back end. The queue can grow from the back end, and the queue can diminish from the rear end. So I can say that there are two ends. As in the case of stack, there was only one end called top, from where the elements were inserted and from where the elements were deleted or taken out. But in this case, in queue, we have two ends. Number one, the rear end, from where the element is getting stuck onto the queue. They are getting added to the queue from the rear end. Every person who is going to take the service has to stand in the queue at the last. He cannot come to the front and have a seat to get a ticket. Okay, so that means whenever a person or a particular element is going to request on a queue, that particular element has to be placed at the rear end or the last end. Okay, now the services, whenever the counter services are given, if this particular element is getting the service first, it will come out of the queue. So that this particular element, the second element, gets the opportunity next from opportunity next. So we can say that there is another end which is known as front. And this front always keeps on moving, because after this 40 is getting its services, this front will move to 65, because the 65 will move on to the front. So we can say that elements are getting deleted out because services are being requested out or are given. The services are given from the front end, and the elements are keeping adding on from the rear end. So there are two ends in queue for this typical type of arrangement, the FIFO arrangement, the front end and the rear end. From the front end, the elements are getting services. From the rear end, they are coming up and adding into the queue to get the services, to get their turn to have their services. Okay, so this is particular case. In real life situation, there are many scenarios where the queue data structure will be used, and you will also see that in some programming situation also, computer programming, it also demands queues implementation. We will have a separate lecture session on this particular topic. Now let us move on to the next type of data structure known as trees. It's a type of non-linear data structure. Mind it, trees are type of non-linear data structure. Now what is the difference between linear and non-linear data structure? In linear data structure, the elements are linearly fashioned. They are arranged in a fashion which is linear in a way. For example, you have seen in array, in queues, in linked list, in stacks. The elements somehow they are arranged in a linear fashion after one another. But in case of trees, which is a non-linear arrangement, it is a non-linear arrangement. I can say non-linear arrangement. It is a non-linear arrangement. In case of trees, which is a non-linear arrangement, here the elements are not linearly arranged. They are hierarchically attached to each other. They are having a parent-child relationship between them. The concept is that they are having parent-child relationship between them, so that one particular node having data is connected with other node in a fashion that it has several childs attached to it. It has several child attached to it. Now this particular node can have one or more child data attached with it. This particular chain again can grow and have child data attached with it. Likewise, this can also grow and have a chain of other data or the child data attached with it. So this type of particular structure, this particular thing is called as node. Mind it, these are called nodes. As in case of linked list, similar type of implementation is here also. They are known as nodes. I must erase this one. They are known as nodes. Okay, this is also another type of child node. So we can say that we have a node A which has two childs, B and C. Again B has two childs, D and E. Then I have another node here, another child of A called X. It has Y and Z childs. So in this way, in a similar fashion, we can have separate other nodes, and this tree can extend up to certain level, up to a maximum level. How many levels you can extend? You can extend this tree up to several extent, up to maximum level you can extend it as per your requirement, as per your need, as per your programming need, you can extend it. Okay, so this is a type of non-linear arrangement of data, and this data structure is also very much important in various types of situation which needs fast arrangement of data in a manner so that we can access the data in a faster manner. We can perform search operation on those data in a faster manner. We can have other serious algorithm, complex algorithms working on this, but on a set of data very fast. For those purpose, this particular data structure trees are essential. Now let us move on to the next data structure, which is known as graph. This is also type of non-linear data structure. I must say that this is also type of non-linear data structure. This data structure actually, as I have said, I have told you in lecture 1. I must have explained you about that Queensberg bridge problem. We have discussed Queensberg bridge problem in our previous discussion. In that discussion, we have seen that we have an arrangement of islands connected with bridges, something like this. We have islands connected with each other through bridges. They are connected to each other by bridges. There were several islands and they are being connected with each other by bridges. So a graph is something, some arrangement like this one, where these vertices are known as, or the vertex are known as the nodes, and connection between two vertices, a connection between two vertices is called an edge. Each of these edge will have a certain weight attached with it. In a graph situation, each of these edge will have certain weights, and these weights can be in terms of distance, in terms of cost, in terms of other physical units. Okay, so some weight will be attached with these particular edges. For example, in a map situation, say I have one destination. From this destination, if I am traveling to another destination, then the distance between these two destinations is, say for example, 240 kilometers. So this is one scenario where the edge will be having a weight called 240. Say for example, I have Visakhapatnam, Vizag, and then I have Rajmundari, another place. The distance between Vizag and Rajmundari may be 240 kilometers. So I can, in a graph, I can accommodate them in a graph such that Vizag constitutes one edge, one node, Rajmundari constitutes of another node, and the distance between them will be an edge which will having a weight called 240. So likewise, in real life situation, we arrange nodes and their edges in the same fashion. Okay, we will see different types of things. You will observe graph theory. You will learn graph theory in your higher classes when you will be going on to the engineering degrees and all that. You will be learning this graph theory in much detail, in much depth. If you want to learn this graph theory, you can do it by learning books on this particular graph theory. There are books available. I will give you the name of references going through which you can learn this particular graph theory in much detail. Okay, so I hope this session is a wonderful session for you, because you have learned basic things about few of the available data structure and few of the data structure that we are going to concentrate. We are mostly going to concentrate our further topics on linear data structure. That is, we are going to learn arrays in much detail, we are going to learn linked list in much detail, we are going to learn stacks, we are learning queues. Graphs and trees are not in our +2 syllabus, so we are not going to concentrate on those particular topics, but still if you have opportunity to read about them, go through a library book and read about it. So with this I am concluding my session. Let us hope that we can implement some of these data structure in our future session. Thank you and have a good day.